we're going to talk a little bit about naming ionic compounds. And when we name ionic compounds, we have to keep a couple things in mind. First, we have to know how to identify that these are ionic compounds. And we've talked a little bit about how ionic compounds typically have a metal bonded to a nonmetal or a metal bonded to a group of nonmetals. And some metals we actually know the charge of and some we do not. And so the first example over here has ions, monatomic ions, that we know the charge of based on their location on the periodic table. So if we're going to take this name and write a formula from it, we have to look at the periodic table, and we notice that sodium is a +1 charge from the periodic table, and oxygen, when it forms an ion, is a -2 charge. Now, when we write these formulas from the name, we have to make sure that they have a neutral charge, and that means all the positives are countered with the negatives. And so we know that this is +1 and this is -2, so we're going to need 2 of these. So the formula is Na2O. We always make sure that we have the lowest numbers and that this is a neutral compound. And we call that a formula unit, and it's very similar to an empirical formula. So we would never write Na4O2, we want the lowest numbers possible. So we can get those charges directly from the periodic table. For the center one here, we know we can also get the charge of potassium from the periodic table. It's right underneath sodium. And sulfate we just have to have memorized. And so sulfate is SO4 -2. We have the same situation over here, is we need to have 2 of these potassiums to neutralize that sulfate. So we would write K2SO4. And that's the formula for potassium sulfate. The last example has a transition metal of which the name has to provide the charge of it. So when we look at this, this 3 tells us that this is iron +3. The sulfide we can get directly from the periodic table is an S-2. Now, we have to make sure this is neutral too when we put it together. And so we know a common number for these would be 6. You can also use that method where you bring the charges down to figure out how many we need. But again, we need 2 of these to make 6 and 3 of these to make -6 to make it neutral. So we'd have Fe2S3. All 3 of these compounds are ionic compounds. Typically, we know a metal bonded to a nonmetal is an ionic compound, and so it's composed of ions.